Hi everyone, in this video we're going to go over another dynamic programming question, climbing stairs. Major tech companies like Google, Facebook, Microsoft are asking this question while they're conducting their technical interviews. I hope you'll find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. You are climbing a staircase. It takes n steps to reach to the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So there are n steps and we can either climb 1 or 2 steps, and we need to find how many distinct ways we can climb to the top. Let's see the examples to understand better. So if the input is 2, if there are 2 steps, then we have 2 distinct ways. Let's see here. We can either climb 1, 1 or 2 steps, because we can only do 1 or 2 steps. 1, 1 and 2 steps, 2 distinct ways. So we return 2 for 2 steps. If we have 3 steps, we have 3 distinct ways to climb to the top. Let's see this. First one. Second way, and third way. So I can either go 1 step, 1 step, 1 step, 2 steps and 1 step, 1 step and 2 steps. So I have 3 distinct ways. And let's see the other cases as well. If I'm on the ground and I have 0 steps, then I return 1. This is important for this question. I have 1 way of going. If I have 1 step, then I have 1 way as well. So these are the base cases for our dynamic programming array. So basically we will follow a bottom-up approach. We will solve smaller questions, smaller parts of the question, and go towards the end. And following bottom-up approach, we'll use dynamic programming to solve this question. Let's see for 4 steps and how does that look. I have 1 way, 1. 2, 3, and the fourth one is 1, 2, 3, and 4. So 2 steps, 1 step, 1 step. And 1 step, 1 step, 2 steps. So 1 step, 1 step, 1 step, 1 step, 2 step, 2 steps, 1 step, 2 step, 1 step, 2 step, 1 step, 1 step, and 1 step, 1 step, 2 steps. I have 5 distinct ways of climbing up to 4 steps here. So let's write down and see the pattern. This is following Fibonacci series pattern, and for example, if you're on the ground and steps is 0, we have 1 way. If you have 1 step, again we have 1 way. If we have 2 steps, we have 2 ways of climbing. If we have 3 steps, we have 3 ways. If we have 4 steps, we have 5 ways. So if you follow this pattern, for example, for the fourth step, we always add n-1 to n-2, because Fibonacci series are fn is equal to fn minus 1 plus fn minus 2. So in this case, in fourth one, it's 3 plus 5. 3 plus 2 is 5. Fn minus 1 plus Fn minus 2. For the third one, Fn minus 1 and n minus 2. 2 plus 1, 3. For this one, Fn minus 1, n minus 2, and 2. So this is the pattern we need to follow. We are saving this into the array, and we will eventually we will use the saved numbers, the previous calculations. That's why this is a bottom-up approach in dynamic programming. Let's see this in the code. If array is empty, so we return 1. We create the DP array. You can call it DP. You may see it in other places as DP, but to make it clear, to more understandable, I call it ways. The reason why we do n plus 1 is because we also count the 0 level when there are no stairs. So that's why we add n plus 1 here. Our array starts from 2 because we calculate I minus 1 plus I minus 2. We add these numbers. So to stay in bounds, we need to start from 2. And we need to take care of the 0 and first cases separately. And these are 1 anyway. From 0 and 1 is 1. And this is pretty much it. And we finally return the very last numbers from the array. This is very typical dynamic programming array solving. So if you see this other places, you may recognize easily. We create the DP array, set the base cases, go through the array, set the numbers, and finally return the last element. Let's submit and see if it's going to work. So this works. I hope this made sense to you guys, and I have more videos coming up, so if you subscribe to my channel, we can meet again later. Thanks for watching. Goodbye.